Today I'm going to speak about PHI, PII, hide and seek, seek and hide. Story how we were seeking protected health information in our Elastic, how we were hiding results, and what we was going to achieve, what we achieved, and what's possible to achieve using Elastic capabilities. To begin with, this story started in PointClickCare, Canadian software company, which develops software for post-acute care, for senior living facilities, and which is a leader on North America market in this segment. Today, millions of Americans, all major US government healthcare plans, more than 70 main healthcare systems, hospitals rely on PointClickCare software on 24/7 basis to take care about patients. Usually, you get a record in PointClickCare software when you're either too old and need to live in special assistant facility, or when you just get discharged from hospital and you need some extra care for a period of time with post-acute care. And in PointClickCare, we are using Elastic, but before we start in fun with Elastic, let's do some boring stuff about legal. Nobody likes legal, but when something happens, sometimes unavoidable to deal with them, because we are dealing with healthcare. And when I just joined PointClickCare, I found that healthcare information is even more sensitive than, for example, your credit card number. Any ideas why? Very simple, you can replace your credit card. Just call your bank and say, guys, I lost my credit card, please replace it. They will change your credit card number, expiration date, etc. But you cannot change your health. That's your body, that's your story, which comes always with you, and it's unchanging. That's why in 1997, HIPAA Act was set by US government to protect this, what they call protected health information in US or personal health information in Canada. And it's very strict rules how it should be protected. Term PHI, protected health information or personal health information in Canada, includes all your interaction with healthcare system, all your payments, all your health records, all your diagnoses, all your histories, all your identifiable information. It's important part. Because in security you often can see term PII, personal identifiable information, which is subset of personal protected health information, because it's only identifiable information which allows to identify you as an individual. And what's most important part, if, for example, I give you a health record of John Smith who lives in New York on 123 Common Street, what happens? For next up to 10 years, I will need to care about any food, shelter, or clothes, because I might spend this up to 10 years in jail for doing it. That's protected health information. It's very serious. But if I give you health history of a male from New York, without any other identifiers, just story of his temperature, weight, I might lose job in PointClickCare for disclosing this information, but I won't go to jail, because if you remove personal identifiers from healthcare information, it's not PHI anymore. If you cannot identify individual, all other components of healthcare information became safe. And if you are legal research university, if you are doing some clinical researches, you might contact the healthcare system and ask, guys, I need anonymized health information from the following groups. For example, I need seniors between 60 and 70 with the following diagnoses. And they might be willing to disclose it, but completely anonymously. You won't be able to find these actual seniors. And in this case, it's safe information. That's the important part for all our story. In PointClickCare, all PHI information are stored in its production environment, protected from unauthorized access. Our applications, of course, we are dealing with health information. We have a lot of it, and all our application producing logs, which are stored in Elasticsearch. And if you're an engineer and you like to access these logs, it's possible. But you need to pass special training. You need to be allowed to access these logs, because logs are stored in Elasticsearch. And Elasticsearch with full stack Kibana runs inside the same protected production environment. That's why even if something leaks from our application to Elasticsearch, it stays in our protected environment. Nobody able will access it without authorization. However, one day security asked us, guys, we understand that it's protected, we are safe, but can we make sure that our logs do not have PHI, just to minimize surface of attack? And we start scratching the, well, an ideal case, it should not, but we have application, first line of code was written 20 years ago. Millions lines of code, 50 software teams working on set of applications. It's really hard to see what we have and what this application is logging. So we start our hunt for PHI information to make sure it won't have in the future. It was not easy, because on daily basis PointClickCare produce approximately 20,000 events per second to Elastic. Huge amount. Anyone who likes to read it, each event, to make sure it no PHI, because nobody able to do it. If you ask all PointClickCare employees to do it, they won't be able to catch up. We need some modern solution. We started from existing solution on market, using Microsoft Senior, scrubbed up, or other items, running off powerful Databricks cluster, and miserable failed. Because first of all, they produce a lot of false positives. Secondly, none of these solutions was able to catch up with our logs flow. We are producing too many logs for them. We realize that we will need huge Databricks cluster, very expensive, which will cost thousands of dollars per day, just to scan all of these logs. No way to go. Fortunately, Elastic gave us a hope. A couple of years ago, they published a very interesting blog, how to get rid of identifiable information using new Elastic features. And it was two main features in Elastic ingestion pipeline: reduct processor and inference processor. Who is familiar with Elastic ingest pipelines? Great, we have at least some people who know what it is. That small set of processors pieces of configuration code which you can put in Elastic to process all your incoming events. And maybe apply some transformation. You can drop some events, change some events, filter events. And Elastic and Elastic 8 offer two new features. First of all, reduct processor, which allows to use regular expressions to find some pieces of information and replace it with fixed strings. And another more interesting part, inference, which allows you to use artificial intelligence or machine learning. So you can grab any document which comes in Elastic pipeline, feed it to a model, even third-party model which you can download from Hugging Face, and ask this model to do something. For example, there are models to identify natural entities in text. Exactly this model was demonstrated by the Elastic, and it was perfect fit for our scenario. So we decided to use it and start getting our hands dirty. First of all, we need to list what we can identify in our logs, what information we might have, and how to clean this information. Remember, we need to find, first of all, personal identifiable information, because if we cannot identify individual, well, we are safe. It's not PHI, it's just some numbers. But if we can identify individual, potentially we're in trouble if this record goes outside of our safe environment. They're safe and safe environment, but we are dealing with security who likes to think what if. We identified 9 most important items, like patient name, patient address, social insurance number or social security number in the US, date of birth, Medicare, Medicaid numbers, phone, email, credit card number. And starting piece by piece, how we can catch any of these in any event. Fortunately, 7 of them can be easily catched by regular expressions. So first Elastic proposal using reduct works fine. But person name and person address, you cannot detect it by regular expression. You need something smarter, and this smarter is artificial intelligence or natural entity recognition machine learning models. Connected all pieces together and face some reality challenges. Regular expressions to detect social security number in US look simple, but when you actually put and start checking logs, you find that it's not really simple. It is a lot of false positives. That's in which regular expression we conduct to detect one of possible combination of social security numbers. So we need to make sure it's sequence of 3 numbers with spaces between them. We have another one for dashes. But it should not be a number in front of them, because in other case it's just sequence of numbers, it's not social security number. It should be space or some separator, or should be word, and same after. If it's not 4 but 5 digits at the end again, it's not social security number, it's something else. And we don't like to scrap something else because our engineers won't be happy. They need these other numbers for troubleshooting. Because it might be some IDs, some timing, etc., etc. They like to get from logs valuable information to support our application. Another big challenge was date of birth. It's easy to detect a date using regular expression, but how to detect that this date is actual date of birth of the patient? Any idea how to detect date of birth of a senior person in a text?
It should be before 1990.
Right, smart guy. It should be 19, so year should be in past century. That saved us. We decided, okay, if in our today log we have a date which is from the past century, there is a very high chance that it's date of birth. So hide it, obfuscate it. But if it's in this century, well, that's not senior. So probably we are not facing something just date. Order, date of order, date of medication prescribed, maybe something else, but it's not date of birth. And most important, we do not need to right away clean our logs. That was our another issue. We need to identify the piece of software which produce this log record. And then catch developer say, no, 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 do not log date of birth in log file. Understand? Nowadays everybody understands, but unfortunately we have 20 years old software. And 20 years ago, not everybody understands how important it is. Another challenge was detecting patient names and patient address. Thanks to Hugging Face, it's possible to very easily test models right on Hugging Face website. So we tested more than 50 natural entity recognition models. We have set of predefined phrases. We fit this phrase to each model and look what will be output. You might see output from 3 different models, and you might see how different it is. Some models were able, top one, pretty accurately recognize address, person name, but recognize that Kibana and Kafka not actual person names. That's something miscellaneous. But another models treat Kibana as 2 words and John as a patient name, but Per as a staff name. So after testing 50 models, we finally was able to pick up one which produces the best results. The best, not ideal, but the most what we expected to get. And we built everything together. Then we realized that for real data, this model still producing a lot of false positives. So we end up having a list of items which should be ignored. We need to ignore all pointing name. That's very valid if you address somewhere in US. That is location, but who cares if it's information about someone from US? That's safe. Same country, county, province, even big cities. We okay if you have information about someone from New York. You won't be able to identify this someone in New York. And sometimes this model also gives treat common Java parameters as a name too. So finally, all items were collapsed together. We build this process, we run it, and logs stop flowing. All test files fine. They're supposed to flow, but Kibana shows that no more logs. Then we realize performance. Unfortunately, machine learning approximate inference time for single logs 50 milliseconds. 50 milliseconds is nothing, but when you have 20,000 events per second, 50 milliseconds become too much. So logs actually flowing, but they were collecting in buffers before get to elastic, because machine learning unfortunately was unable to process our logs in real time. Any suggestions what to do?
Batch.
We have 2 billion survey per day, so we either need to increase our compute capacity 9 times.
No, you have to maybe have another storage like you have the initial one that gets aggregated, and then you have another one.
Yeah, but again, we won't be able to catch up with real time.
So that
To
won't be real time.
process. On the other hand, again, we do not need to clean up right away. We need to identify pieces. So our decision was, let's split this process. Let's keep reduct processor, which using regular expressions to scribe sensitive information like social insurance number, date of birth, credit card number. Fortunately, no credit card numbers at all for this kind of. And let have separate pipeline to occasionally scan logs for patient name, patient address, and then talk with software teams who is responsible for this specific log line to fix the code and no logs anymore. So yes, your suggestion was partially right. It's batch, but we decided to skip some pieces because again, logs are still in production environment. Logs are still safe and not accessible with third-party persons. But we just scanning not every day of logs, maybe every fix. And it helped us to identify some pieces of code, communicate with teams, and teams complaining but start addressing it, especially after short conversation with security. Security can empower developers to work very quickly. That's what we have today, and plans for future. First of all, expand detection. Scan all our logs. For today we are scanning our main applications. We like to cover everything. Unfortunately, we need to adjust pipeline, not same size works for all. Like for example, to scan a PHI in URLs, it's completely different just to scan normal log messages, because in URLs your regular expressions will be different. Then track our fixes. Make sure that all identified places were fixed properly and no more PHI information comes from these places. But in future we need something to automatically notify us about new spikes, about changing in detected patterns. That's where we are going to our elastic machine learning to detect anomalies in our processed logs. That's our state for today. Looking future. Thank you. Any questions?
Regarding the elastic, can you go to the slide where you divided this one thing here? So does the machine learning filters, let's say, applies on the based on like developers searching something in Kibana, or how does that work? What is basically what goes through machine learning filtering?
Machine learning actually uses update by query, elastic functionality. It's possible to specify pipelines in update by query. So we run for specific day of logs, we run update by query and run all logs already ingested in Elastic through machine learning pipeline. And in this pipeline, machine learning identify possible log records which contains PHI, put a flag on this record. Then for today we have to manually review it and say, okay, there's no one, oh, it's something new. We didn't see it before, so let's communicate with proper team. So that's how it runs for today. Yes, unfortunately, it's very slow to run the same like we have for regular expressions to scan all incoming logs.
You talked a lot about false positives, but you didn't mention false negatives, which to me seem a little bit more serious because it's not redacting something that shouldn't be redacted, it's forgetting to redact something that shouldn't. Do you have problems with that?
No problems, but we developed an extended bunch of tests. So every time we make a change in any of these pipelines, we run these integration tests and automatically make sure that all examples of PHI information detected. So our pipeline is still able to detect at least what we already expected.
Yeah.
If we find something new, for example, another format how date of birth can be stored, we will improve our suite of tests. But exactly for our case, false positive were more important because when you have out of 2 billion surveyed per day, maybe just 10,000 events which was marked as potential PHI, but right away with out of these 10,000, 8,000 that message about username, not because some organizations using emails as a username. And of course our regular expressions say, oh, you have email, not allowed, it's PHI. But it's not actually email, it's username. And we can disclose this information because it's username, we can keep it. We not just can store it in log, we need to store it in log to see actions of this specific user.
The ML pipeline that you have, is that deterministic? Like if you run it on the same inputs, you'll get the same output?
Always get the same.
Because that would be also very important.
Yeah. Any other question? Yeah.
How much throughput did you end up getting? Like how many messages per second were you processing?
We have 2 billion events per day, and pretty all of them goes through regular expressions to redact sensitive information information like social insurance number, date of birth, credit card, email, etc. But we just run every fifth, every seventh day through machine learning pipeline just to do not pay for more for compute. So again, we need to increase our compute power on Elastic Cluster approximately 9-10 times to be able to run it with speed we can't to our system. Yeah?
Speaking of the performance, like, what would be the accuracy of the entire submission of detecting the information?
From performance, we were able to run it completely on the same hardware, same infrastructure. This part, no extra cost, and our financial department was very happy with this. This one also no extra cost because we decided not to increase power, just run not all events.
Yeah, and what is the accuracy of detecting correctly all these information? Like, is it like 60% you're able to get?
All known cases which we have as our test suite detected correctly. So we hope it's pretty high. And again, our goal not to have right away everything clear, but first of all catch log messages and communicate with producer of these log messages to correct producer. Because, understand, it's much harder to work here to recognize that this date. Because, okay, you have, for example, 16-digit number. What it is? Is it just foreign key or is it credit card information? Hard to say here. But when we speak with developer, well, your code producing exactly 16 digits numbers. What it is? The developer can say, yes, it's external third-party primary key. Okay, we'll make extra condition here to ignore this piece. Because that's false positive, that's not credit card. Same for social insurance number, which is even shorter than just number. Or maybe developer look and say, oh yeah, that was social insurance number. Okay, so you know what to do.
And how much by adding the machine learning pipeline will be able to improve the accuracy?
Machine learn, they have
Is it
two
as like a
separate
complement?
items because machine learning used to detect these two items.
Okay, only these two.
Yes, all others detected by regular expressions.
Okay, fine.
Yes?
Just curious, I'm wondering, do you do any filtering or scanning for stuff like rare conditions or like health information that for most people wouldn't be identifying, but in rare enough conditions or things like that, a couple of medications can identify somebody because there may be like only a few million, maybe only a few dozen people in a population that have that condition, and so you have to be more careful about that kind of data.
So if I understand correctly, if you have a log record that, for example, Tylenol 350 was prescribed for patient 1 to 3, it's not a PHI because it does not have identifiable information. It has just internal patient ID, which not exist outside of PointClickCare, which you cannot translate to real person unless you get access to PointClickCare database.
But if you could theoretically say that this is the only person that is on these 3 medications, you know, still no?
No way. Again, you have even 3 records, the 3 medications were prescribed to an abstract person. But you need to know list of person who getting these medications. And if you do not have this access, if you already have access to person history, you might say, well, I know one guy who was prescribed 3 similar medications. I cannot be sure that it's the same guy because again, no personal identifiable information. We have millions of Americans recording this. Very high chances that there is someone else. Lots of someone else.
And what was the timeline for you to like make this up from the moment when you start hunting for these like PHI API events to the state you're now? how long the journey took?
Initially, we started maybe a couple years ago with this Microsoft Studio, and unfortunately got stuck. But when Elastic gave us a hand with new features, maybe half a year. Not dedicated work, because it's not money generating project, but in the same important for security. So side project was running, and half a year we were able to achieve current state. Fortunately, Elastic is pretty convenient to use. Any other questions? Thank you very much for your time.